So this video will give a brief overview of Chapter 5. So Chapter 5 deals with finding the area underneath a curve. So let me draw my basic quadratic. And let's put in some marks. So we're going to find the area of the curve. So we know how to find area of rectangles. So if I draw some rectangles that look like this, we could then, not very straight, we could then take and find the areas of those rectangles and add them together. And we can see, well, there's a lot of extra area in there that would not really be part of what the area wants. And so we have here that the more boxes the better the fit. So instead of doing 4 boxes, if I did 8 boxes, it would be even a better value, and so on. Right? So you get in terms of what is called Riemann sums. So let's look at it in terms of y equals x squared. Right? And so there's, in terms of Riemann sums, there's 3 variations. There's the left sum, there's the right sum, and then there's the midpoint. So let's look at my y equals x squared. And I want to know from 0 to 2. Okay? And I want to divide this up into 4 intervals. And so the way I can get my marks would be, well, this is going to be 2 minus 0 over 4. So this is going to be 0.5, 1/2, right? So that means I'm going to have 0.5. So we're going to start at 0. We're going to have 0.5. We'll have 1. We will have 1.5, and then we will have 2. So we can divide that up into my intervals. Right? So the left sum means we're looking at the left endpoint of that box. So in terms of my boxes then, this will be 0 squared, which will be 0. This will be 0.5 squared, which is going to be 0.25. This will be 1 squared, which will be 1.0. And then this would be 1.5 squared, which would be 2.25. And I could add these together, and I get 3.50. Right? So now, if I go to the right sum, still using the same intervals, right? So now we're looking at the right side, and so this is going to be 0.5 squared, which is 0.25. This will be 1 squared, which will be 1.0. This will be 1.5 squared, which is going to be 2.25. And this would be 2 squared, which is going to give us 4. And so we could add that up. And this one gives us an area of 7.5. Okay. And then we could do the midpoint sum. So the next one is the midpoint sum. So now we're halfway in between. So this is going to now mean 0.25, 0.75, 1.25, and then 1.75. And again, we'll square each one of these. And so now, in terms of the areas, this is going to be 0.0625. This is going to be 0.5625. And this will be 1.5625. And this one will be 3.0625. And again, I can add these up. And this time we get an area of 5.25. So we get quite a variety in our answers here in terms of the range. We go from low of 3.5 to a high of 7.5. So there is quite the variation between these numbers. Let's just bracket these off one from the other. All right. So we have in terms of Riemann sums, and so we can do left, right, or midpoint. Right? And then we get in terms of integrals. So integrals basically has to do with finding areas. All right. So definite integral. So for example, I want to know the integral from 1 to 3 of 3x squared plus 2x plus 1 dx. Right? So if I integrate this, I'm going to get 3x cubed over 3 plus 2x squared over 2 plus x evaluated from 1 to 3. But of course, I can first do a little simplifying here. This will give me x cubed plus x squared plus x evaluated from 1 to 3. And now we plug in our numbers. So this is going to be 3 cubed plus 3 squared plus 3 minus 1 cubed plus 1 squared plus 1. So this is going to give me 27 plus 9 plus 3. So this will give us 39 on this side. And then over here, we'll have 1 plus 1 plus 1. And so we'll get a minus 3 over on that side. And we end up with an area of 36. Okay. Now let's look at this one. We're going to integrate 1 to 6 of 2x minus 6 times t. Right. So again, if I integrate this, it'll be 2x squared over 2 minus 6x, which will become x squared minus 6x evaluated from 1 to 6. So again, we plug in their numbers. This is going to be 6 squared minus 6 times 6 minus 1 squared minus 6 times 1. So this is going to be 36 minus 36, which is 0. And this is going to be 1 minus 6. So this is going to be minus a minus 5. And we end up with an area of 5. Right? And so if we look at the graph of this and what that will look like, 2x minus 6, if we graphed it, it's a line that goes like this. And so we went from 2, so let's say this is 2, to 6, which say is here. So the way we work in terms of area, if it's under the axis, under the x, the area is negative. And then if it's above the x, area is positive. So the answer we got here is the net area. Because part of it was below, part of it was above, and so this is nice little simple triangles. It ends up that the area below here was 4, and the area above here was 9. And 9 minus 4 gave us 5. Now, well, then you get into the fundamental theorem of calculus. And so if f is continuous, on the integral a to b, whatever that might be, then the area function so a of x, so area, is the integral of a to b f of x dx for a less than equal to x less than equal to b, right? And then when we integrate from a to b of f of x dx, this is f of b minus f of a. So integration and differentiation are inverses of each other. So for example, if I said the derivative was 2x plus 3, and I want to know what is the original function, well, I can integrate this, 2x plus 3, and so this will give me 2x squared over 2 plus 3x plus c, so x squared plus 3x plus c, right? And this was the original function, right? And then if I had a bit more information, I could actually tell you what the c is. So if I had a bit more that I knew about this. And if I were to start out with x squared plus 3x plus some number, and then I took the derivative, I would end up at 2x plus 3. The other thing they mentioned in this chapter, they talk about even and odd properties. And that it can make things easier to solve. And so let's just look at that briefly. So for example, first off, even. So let's do my basic x squared graph is a good example of that. So this is even, after all, it is symmetrical about the y-axis, right? And so even, if you integrate from negative a to a of f of x dx, it would be the same as 2 times the integral of 0 to a f of x dx. So that's even, right? And then the other one they mention is odd. So let's do my basic odd one, which is this graph. Right? So my cubic function. And so here, if you integrate negative a to a f of x dx, well, here it would be 0. Other things they talk about that is average value or mean value function. Average value or mean value. And so you get, is given by this, 1 over b minus a integral a to b f of x dx. Right? So let's look at an example how this would work. So let's say we want to know what is the average value for this. So f of x, x squared minus 4x plus 2. And we want the average value from 4 to 7. Right? So the average value is going to be 1 over 7 minus 4 integral 4 to 7 x squared minus 4x plus 2. So this will give us 1/3 the integral. This is going to give me x cubed over 3 minus 2x squared plus 2x evaluated from 4 to 7. So this is going to be 1/3 up front. right? And so this is going to be, now we plug in. So this thing up front times what's going on here. So this is going to be 7 cubed over 3 minus 2 times 7 squared plus 2 times 7. This part minus 4 cubed over 3 minus 2 times 4 squared plus 2 times 4. So now it's a matter of number crunching all this. So 7 cubed, this is 343 over 3 minus 98 plus 14. This part minus, this is going to be 64 over 3 minus 32 plus 8. And so if I simplify what's in this part of it, we end up with 91 over 3. And then we simplify the back part, we end up with a minus 8 over 3. So this is going to be 1/3, and this is going to be 99 over 3. And so this is going to be 99 over 9, and we end up at 11 for my average value. Okay. And then other thing they mentioned then, last thing here is in terms of doing what is called substitution. So if I integrate, plus 6 to the 9th, x to the 4th, dx. So I can do some substitution here. So I can say let u equal x to the 5th plus 6. Then du is 5x to the 4th. So probably we want to pick our u such that the derivative will be very close to the other term. In this case, my du is 5x to the 4th. My original is x to the 4th, right? And so all you have to do then is say, okay, well, Bailey, this is 5 times larger than the original, so if I do 1/5, and then this is going to be u to the 9th du. So this is going to be 1/5 u to the 10th over 10 plus c. And so this is going to give me u to the 10th over 50. And then the next thing we do is just substitute back in x to the 5th plus 6 to the 10th over 50 plus c. And we get it. Right? And then one more. Let's do this one. Integral cosine squared x dx. So from our various trig things, we learned before that cosine squared is the same thing as 1 plus cosine 2x over 2. Right? So cosine squared x dx is, we can rewrite, is now going to become, there we go. So it's going to be 1/2. And so we're going to rewrite this to be cosine. This is going to be 1 plus cosine 2x over 2 dx, which will be 1/2 dx plus cosine of 2x over 2 dx. So this is going to be 1/2 the integral of dx plus 1/2 the integral of cosine 2x dx. So this is going to be 1/2 x. And then we could say here that, so now in this part, we'll say u equals 2x. And so du is going to equal 2 dx. And so we now get 1/2 times 1/2 integral cosine u du. So this will give us 1/2 x, 1/4, and we integrate cosine, and we end up at sine. And so now we can substitute. And then we'll have r plus c. And actually, I should get rid of this. Plus c, right? And that will conclude this brief overview of that chapter.